Hello, today's topic is topic 1.2, defining limits and using limit notation. I'm going to read the little blurb at the top. Feel free to follow along. It says most functions in algebra are defined at all values of x. However, there are many functions that are undefined at one or more points. If a function is undefined at x equals c, there is no output at that point from which to draw any conclusions. The idea of limits gives the ability to draw conclusions at x equals c by studying the output values as the x values get infinitesimally close to x equals c. So we're not talking about what happens at the point, but what we're talking about is what happens near the point. As we approach it, where is that function going to? So the limit of a function is the value that the function approaches as the independent variable, or x, of the function approaches a given input value. Okay. The notation for a limit is noted as follows. So I have three different notations here. The first one is a left-sided limit. Okay. And what we're going to do is when you have a left-sided limit, we have this limit notation. We always need to be sure that we have the function name next to that limit statement. And then next, underneath the limit, it's x, and then that arrow means approaches a, and this little minus sign, I'm going to highlight it here. We'll dismiss that little box. Okay, this little minus sign means from the left. Okay, so you can see the visual, the blue arrow, as this function approaches the left side of 3, okay, we're at the y value of 2. All right, the output of a limit is always going to be the output of a function or a y value. So a right-sided limit is indicated with a plus sign as a little exponent. So it's the same way. The limit, again, we always need to make sure. For some reason, I have students in the past that forget to write the function name next to their limit. As x approaches a from the right is equal to a value. So from the right is a little plus sign, and you can see in my diagram here, I would follow the right side of my function, and that would give me a different value. It'd give me the value of 3. So to compare the two, the left side gave me an output of 2. The right side approaches the output of 3. All right. And then a two-sided limit is when I approach from the left and the right. Now, in a two-sided limit, there is no exponent or there is no superscript on the a here. Okay, so the limit of f of x, again, I typically put the function right next to it as x approaches a. If there's nothing indicated on the exponent, then it's a two-sided limit. Okay, so in this picture, the left side, as I approach 2 from the left, and as I approach 2 from the right, both of those are approaching the same value. So in this case, they both approach the output of 3. All right. Now, there's a note here. A two-sided limit only exists if the left-sided limit is equal to the same as the right-sided limit. So the original picture we had, the left side goes to an output of 2. The right side goes to an output of 3. These two things are not equal, therefore you cannot have a two-sided limit. Now, to go back up to the top to show you this, here the left side, the blue arrow, and the right side are approaching the same value, therefore we can get an output for that expression. That does have a value. But when they do not equal the same thing, when they approach two different coordinates, that's when that limit does not exist. Okay, so the rest of today's lesson is going to be about notation, writing things correctly. For example, in example 1, I want to rewrite the verbal model as using proper notation. So feel free to pause the video and try and write these examples using proper notation, and then you can unpause the video to kind of check your work. So for part A, the limit of n of x as x approaches 7 from the right is 19. So if I do this, I'm going to write the limit as x approaches 7 from the right. So it needs a little plus sign of I like to use from parentheses my function n of x, make sure all your parentheses are good, is equal to 19. Okay, so that's what it looks like. So if I do the next one, the limit of dm, d of m, as m approaches 2. Now that's a two-sided limit, so it does not get any superscript. That is equal to a negative 13. And then last but not least, the limit of z of x as x approaches negative 11 from the left is equal to 0. Okay, so this would all be proper notation. All right. Now in example 2, I give you a statement and I want you to write 3 limit statements. So the example 2 says write 3 limit statements given the limit of h of t as t approaches 5 from the left and the right is 13. Okay, so the first one, I'm just going to do a left-sided limit. So the limit as t, make sure you're using the proper variable, of 5 from the left of h of t, and that is 13. So that's the left side. The right side, so the limit as t approaches 5 from the right of h of t is also 13. And then last but not least, the limit as t approaches 5. The two-sided limit does exist because we know the left and the right are equal to each other. So we can say that that two-sided limit is going to be 13 as well. Okay. Example 3, same idea. Feel free to pause the video. Write the 3 limit statements given the limit p of m as m approaches 3 from the left is negative 1, and the limit of p of m as m approaches 3 from the right is 2. So I can do the left side. So the limit as m approaches 3 from the left of p of m is negative 1. The limit as m approaches 3 from the right of p of m is 2. And the two-sided limit, now the as m approaches 3, so no superscript there of p of m. Because the left and right sides are different, they're not equal to each other, we are going to say that this limit, as soon as my stylus starts working here, come on. There we go. Does not exist. Okay. Sometimes people abbreviate this as D and E. I always like to write it out. I assume the AP readers don't actually understand all the acronyms we use, so I always like to write things out. Okay. But again, because the left and right-sided limits are not the same value, we're going to say that that limit does not exist. All right. And that is proper limit notation. Okay. So topic 1.2 is how to write a limit. One, just to kind of review, if you have a minus sign as your superscript, that is from the left. If you have a plus sign as your superscript, that is from the right. And if there is no superscript, then it is both from left and right. And in order for that two-sided limit to exist, they have to be equal. So in the first example, they both went to this hole at 3. That was my answer. In this example, there's a little jump discontinuity here. They go to 2 different values, therefore it does not exist. So hopefully now you know how to write proper limit notation. Thank you.